We will proceed to problem number 3 in lamina 3 or plane surfaces 3. A circular lamina inclined to VP appears in the front view as an ellipse of major axis 30 mm and minor axis 15 mm. The major axis is parallel to both HP and VP. One end of the minor axis is in both HP and VP. Draw the projection of the lamina and determine the inclination of the lamina with VP. The problem clearly says a circular lamina front view should appear like an ellipse, whereas he says a major axis 30 mm, minor axis 50 mm. When the major axis is 30 mm, the diameter itself is 30 mm, the circular lamina 30 mm. It is inclined to VP in such a manner the front view should be an ellipse of 15 mm minor axis, 30 mm major axis. Again, we have to rotate the entire lamina in such a manner the major axis is parallel to both HP and VP. The answer goes like this. Start the figure in the front view because the front view should appear like an ellipse. The front should appear like an ellipse. Draw 30 mm diameter circular lamina, front view and top view. Then turn it in such a manner the front view should have 15 mm, 15 mm minor axis. Get the ellipse done. Then afterwards, getting the ellipse, you turn the major axis into parallel. You should make the major axis into parallel to both HP, VP. Initial figure, make it inclined. You have to measure the angle now, making it 15 mm minor axis, then making it 90 degree turn. You find final answer, top view, front view, both will be ellipse. That's the steps you have to carry on in solving the problem. We'll proceed to study the problem number 3 in the lamina 3 title. A circular lamina inclined to VP appears in the front view as an ellipse of major axis 30 mm and minor axis 15 mm. The major axis is parallel to both HP, VP. One end of the minor axis is in both HP, VP. Draw the projections of the lamina and determine the inclination of the lamina with HP. Fine. Yes, very clear says the circular lamina appears like an ellipse in the front view. Start the figure in the front view. The entire concept is been discussed with you in the previous classes. So the 30 mm is actually the major axis, that is the diameter. 15 mm is the minor axis. Draw the circle with 30 mm diameter in the front view. That is the front view I have drawn, top view I have drawn here with the 8-point division. This appears like a 15 mm minor axis, 15 mm minor axis. The circle will appear like ellipse provided the top is inclined. Top is inclined. You measure AE, touch here the VP, cut off the same measurement AE here. That is AE. This is A, this is E. Locate all the in-between points, locate here. This is G, C, all the other points, locate them. You find, you get the ellipse. You get the ellipse here with the major axis and minor axis. You get the ellipse here with major axis, minor axis. So, let me complete here. So we will have here ellipse done here. That is the ellipse. Ellipse. That is the minor axis. That is the major axis. Major axis. The major axis is parallel to both HP, VP. So reproduce the entire ellipse here. Reproduce the entire ellipse here, such that the major axis is parallel. So reproduce the entire ellipse here. Please reproduce the entire ellipse here. Reproduce the entire ellipse here. The 90 degree turn, the major axis is parallel in this manner. Get all the points projected. You can carry on with the 8 points as well as the 4 points, since it is a very simple problem with a smaller diameter. So again you get the ellipse done here. Ellipse done here. You find now the major axis is parallel to both HP, VP. The major axis is parallel to both HP, VP, and that is the major axis. So this has to be turned by a 90 degree turn. a circular lamina 30 mm diameter. I have drawn the front view and the top view, and I have made the 30 mm become 15 mm is the minor axis. I have drawn the two lines, located the front view is drawn here. I can measure the angle. This angle also I can measure the angle. I can measure the angle, get the what is called the angle of inclination. Now we have the ellipse here, minor axis 15 mm, major axis 30 mm. Turn that major axis 90 degree turn and see that touches the XY line both. The one end of the minor axis, basically draw the projection, minor axis in both HPVP, one end of minor axis, both HPVP. So we find the minor axis, both HPVP. This point is actually A dash. So you get here A dash as well as A. One end is touching both HPVP. That's why you have to plan and rotate the entire figure. Plan and rotate the entire figure such that we get what is called as the point here, 90 degree, with a 90 degree turn, you get the point here. That's the final view.